So, welcome to the third unit, that is the routing protocol. So, already we discussed about the unit 1 and 2 materials. So, the title on the screen is Unit 3 Routing Protocols. Let's break down that before we go anywhere else. So, the word just means that is the full one block of our syllabus, a self-contained chunk of this course. So, this is the third major section of the subject, which usually means you have already covered Unit 1 and 2. Typically, the physical layer and the data link layer, or an intro to the networking and IP addressing. That intro, that matters because everything in this unit assumes you already know what an IP address is and what your router does, does at a basic level. Routing protocols, let's take the phrase into two words, the routing and the protocols. So the first one is the routing. This is a verb tuned into a noun. So it refers to the process of choosing a path. In networking, we can say routing, we specifically mean the process by which a packet's journey from a source device to a destination device is decided, hope by hope across a network of routers. Protocols, a protocol in networking is simply a set of agreed upon rules that devices follow so they can communicate correctly. So, routing protocols put together means the set of rules that routers follow in order to decide and agree with each other on the best path for a packet. Now, look at the image on this slide. It is captioned routing versus routed protocols. Routing versus routed protocols. Uh, This is deliberately shown here because these two terms are the single most commonly confused pair of terms in this entire unit. So it's clear it up the right of the start. A routed protocol is a protocol that is actually routed, meaning it is the protocol whose packets are the ones being carried and delivered across the network. The most obvious example is IP, the Internet Protocol. So, IP packets are the actual data, your emails, your video calls, your web page being carried from source to a destination way. So, IP is called a routed protocol because it has the addressing structure, source and destination IP address that allows to it to be routed in the first place. So the routed protocol, on the other hand, is not about carrying user data at all. It is the protocol that routers use amongst themselves. Router to router to build, exchange, and update their routing tables. Examples: you will meet in this unit or RAP, OSPF, and BGP. These protocols don't carry your Netflix video on your email. They carry routing information. Here is what networks I know about and how far away they are. So here's the one sentence way to keep this straight for the rest of the unit. IP is the inter protocol that gets routed. RIP, OSPF, and BGP are the protocols that do the routing. Finally, notice the notice the different categories of the routing protocols in this slide. So these are the topics we are going to discuss in this unit. The reference materials is you can refer better Feroz Khan and William Starling's reference book, Data and Computer Communication books. It is a very good reference when compared with all the books. So the first one topic is the forwarding IP packets. This is the most fundamental building block. Before we can talk about routers exchanging information with each other, we need to understand what a single router does with a single packet. How does it decide right now which interface to send it out of? That is forwarding, and is covered first because everything else depends on understanding this basic mechanism. So the second one is the static and default routing. Once we know what forwarding is, we look at the simplest possible way to fill in a routing table by hand statistically or by using one difficult default catch all entry. This is the baseline before we get into automated dynamic methods. The third one is the unicast routing algorithm. The word unicast means one to one communication, one sender, one receiver. This line is a header for the next three lines, which name the three major algorithm families used to compute unicast routes. So the fourth one is the distance vector routing. We abbreviated as the DVR. This is the first of the three algorithm families. Routers learn about the network by talking only to their immediate neighbors and sharing distance information. So the fifth line is the link state routing. It is abbreviated as the LSR. This is the second family. Instead of only talking to neighbors, routers build a complete map of the networks by flooding information to everyone. Sixth one is the path vector routing. This is the third family used specifically for routing between independent networks where policy matters more than raw distance. So the seventh one is the RIP dash V1, like version 1, version 2. RIP stands for Routing Information Protocol. This is a real deployed protocol that implements distance vector routing. So the V1 and V2 tells us we will study both of its historical version and the differences between them. And the next one is the OSPF, BGP, EIGRP. These are the three more real protocols. OSPF is nothing but open shortest path first. Implements link state routing. BGP is nothing but border gateway protocol. Implements path vector routing. EIGRP represents the enhanced interior gateway routing protocol. So it is mentioned here as an additional protocol. A Cisco developed a hybrid protocol through the tech does not dive deeply into in later slides. So the last one is the multicasting basics IPv6 addressing. So this tells about the unit closes with two additional topics that build on everything before them. Multicasting, which is one to many communication, and IPv6 addressing, the next generation addressing scheme. So the references are the Ferroscon and William Stallings.